second grade. How are you? Yesterday we tackled some doubles. We looked at how we can add together two numbers that are the same, and then we even use that to help us subtract and find the missing answer when we were subtracting. And our numbers were not too big, and today we might be getting into some a little bit bigger numbers. We are going to be diving into actually something called a near double. Near means close. Let's tackle this CLT, or this learning target, first, and then we'll get into these problems and think a little bit more about these words up here, especially that idea of near doubles, to help us solve it. So let's pull this back. I can use near doubles to solve addition and subtraction problems. What is a near double? You've heard that from first grade, haven't you? Near means close, and if it's close to a double, it's a near double. I just heard somebody say sometimes we call it a doubles plus or minus one. You're right. It's just one that's one away from a double. So one of those numbers is off. And we're going to use what we know about that to help us solve these problems today. Our first one is a story problem. Get us warmed up, thinking about something yummy. Sally is baking cupcakes. In fact, I'm going to tuck this up again. You know, I keep forgetting to tuck that up, and I don't want you guys to get distracted and try to solve ahead of the game. We got to focus on this first one first. Sally's baking cupcakes for 2 classes. One of her classes has 14 students, and the other has 15 students. How can a doubles fact help you know how many cupcakes Sally needs to make? Oof. What equation can we write to solve that? Can't even keep you guys quiet. You're right. How does 14 plus 15 equal blank match this story? Class 1 has 14. Class 2 has 15. And she's making them all, right? So how many does she have? Okay. So let's take a few moments and think, first of all, back to those doubles, because we're using those doubles to help us solve this if we can. I want you to take some time to yourself and think, how might I solve this problem? For how many cupcakes is she going to make? I'm going to give you a few moments of private think time. Take some moments to think and then write it down. Remember, you can use pictures, you can use numbers, you might even use words, but how can you solve this problem? Remember, your math toolkits are there in front of you if you need something to help you get started. Where's your 14? Where's your 15? Oh. Would you share that with the class? Okay. What number did you decompose? Could you show it another way? What double are you using? Is there another double you could use? About 5, 4, 3, 2, 1, and done. Go ahead and put your pencils down. We're going to go ahead and share some of these ways. We're going to kick it off with my friend right here. Pop that up on our Elmo so we can see what you're doing. And as you're sharing, I'm going to write down, and I might ask you a few questions along the way as you go. Can you put yours up there so we can see it? What tool did you use? 10 frames help, especially when we're starting out these numbers, don't they? Before long, you'll be doing it all in your brain. Helps be able to picture it first, doesn't it? Okay. Okay. There's your 14. Gotcha. Okay. Okay. And then what did you do? Oh. What about that little guy on the end? Oh, 14 plus 14 plus 1. Well, how do you know what 14 plus 14 equals? 10, 20, and then 4 and 4 is 8, so you had 28. And then what do you have? Got one more. Very clever. That picture helped you see it a little bit, didn't it? Why did you leave that little guy off on the end? Okay, so you saw that double here and that double here, and so it was easier to add that extra one. What number did you decompose? Did you break apart? That 15, right? Because that could have been, that was that 15 up there. Okay, thank you for sharing. Yeah, you used a different doubles fact. Could you share with us what you did? Very interesting. You ready for this one, guys? Okay. Oh, what was the double that she used? 14 and 14. If you used 15 and doubled that one, what? It equaled 30. You just knew that one better. Okay. And then what did you do? Did you add one or take one away? Why did you take one away? Because 14 is 15, take away 1. Okay, it's 1 less than 15. And what's 1 less than 30? Can we use both of those doubles, the 14 and the 14, or the 15 and the 15? Can we use both of them to solve these problems? How do we know? Why does it work to do both of those? Because we're adding one to that one, and we're taking one away. So we can use both of those doubles to help us solve this. I wonder which doubles we might use to solve the next problem. Are you ready for this one? Remember, we talked about addition and subtraction problems, friends. So this one is a little bit trickier, okay? We're going to see if we can use a doubles fact to solve 27, take away 13. Now remember, we have our workup from the other day, from our doubles. So when we use our doubles from the other day and we think about our subtraction, we know that we can use addition to help us solve that subtraction. So don't forget, this chart is up for us to use as a tool to help us, right? So we can use that, and we want to be thinking about how we can check out our other ones to help us remember all the things we can do. How can we use a doubles fact to solve 27, take away 13? Go ahead and get rocking and rolling. Where's the double in that? Oh. Okay. I'm going to put up 2 pieces of work that some of our friends did. And I want us to take a minute. I'm going to do one at a time. And I want each of you to take a minute and you're going to do something called interpret. So when we interpret something that somebody does, we look at it and we think about if we can figure out what they were thinking, right? We're trying to make sense of what they did. So I'm going to show up, I'm going to draw and put up what they did. And I want you to see if you can figure out how they solved this, okay? Now don't guess yet. Give me a minute. Remember, we're going to use what we already know to help us, okay? So you're just going to look and think. Okay. And check out your work a little bit. Okay. What do you notice? They drew out 27. They found 13. Why did they look for 13? There's that 13 that we took away. And what did you notice that she had left? Or that this person's work had left? They had another 13. And then they had that little guy at the bottom, didn't they? 13. This 13. 13. This 13. And then there's that one Lone Ranger, right? And they made 27. So how do they find what went in here? There's the 13 that took away, and there's the 14 that was left. Absolutely. How'd they do? Pretty good, huh? Got another way I want you to see, and I want you to see if you can figure out what this person did. Friends, when we take time to think about what somebody else did, it helps us get a better idea of another strategy we can use, and also helps us think in a different way that we might not have thought before. Why 14 and 14? Because it got you a 28. You didn't know it made 26 or 27. Okay, using a combination you know. And then why'd you take away 1? Took it to 27. Okay. Got one more thinking. And this one probably is the one I think I saw the most. And I saved it for last because I saw it the most. But some of my friends didn't even think about this. And what's the unknown is this one. I wish I could say that I thought of all these on my own, but friends, you second graders are rock stars and you're knowing more and more doubles facts by the day. Remember, we can use doubles facts to help us solve all sorts of problems, right? We can even, when we think about our other doubles, we can break apart those doubles and get to smaller numbers. I'm seeing you be really creative today when you're thinking about either the larger double or the smaller double, and you're either adding one or you're taking one away. We can be creative. We want to make sure that we're being able to think of something that works for us. So it might not be the same as what your partner is thinking, right? Because when we solve problems in our heads, we want to make sure that we're doing something that makes sense to us, that is accurate. That means it's right? Effective. That means it uses efficient is the word I'm looking for. And that means that it gets done fairly quickly, right? It doesn't take you a long, long time to do it. And it's flexible. That's my favorite one. Because when we think about being flexible, that means that it might work. You might solve it this way. Your friend might solve it this way. Or you could solve a problem 2 or 3 different ways, but you're picking the one that works best for you. So don't forget, when we're solving problems mentally, whether it's a near doubles, a doubles, a make a 10, that we are trying to choose a strategy that works best for us to help us solve it in our head. We've got to do this before we can do this.